Welcome to Module 3 Video 2 Building Your First DApp. In this video, we will be building the DApp we saw last time in detail. The tutorial aims to provide you with the comprehensive guide to building a decentralized app from scratch. By the end of this video, you will have a solid understanding of how to deploy, develop, and interact with a simple DApp on the Ethereum blockchain. We are going to discuss some key points in this video. First is introduction to the DApp, what DApp we are building on the Ethereum blockchain. Then we will learn how to set up the development environment, how to write the smart contract, and how to compile and deploy the smart contract on the Ethereum blockchain. Each section will provide a step-by-step guide to ensure your understanding and you can uh, replicate the process on your own. Don't worry if some of the concepts seem new or complex. We'll break them down into manageable pieces. By the end of this video, you will have built a fully functional DApp that you can further enhance and customize. A simple DApp centralized application that allows user to store and retrieve a message on Ethereum blockchain. This is our project. The project will involve writing a smart contract, developing a frontend, and connecting the two using web3.js. Think of it as creating a basic online service where user can submit and view messages but with the backend logic stored on the blockchain. This project will provide a foundational understanding of how DApps work and can be expanded with additional features like user authentication, data encryption, etc. Real world application of this type of DApp could include anything from secure note taking to decentralized social media platforms. To get started, we need to set up our development environment. Install node.js and npm from nodejs.org. Install Truffle running npm install g truffle. Install Ganesh CLI by running npm install g Ganesh CLI. Setting up environment is like preparing a workshop with all the necessary tools for building our project. Now let's write a simple smart contract in Solidity that allows user to set and get a message. This smart contract is the backend logic of our DApp. Solidity is a statically typed program language designed for developing smart contracts to run on Ethereum Virtual Machine or EVM. Smart contracts are self-executing contracts where the terms of the agreement are directly written into code. Let's break down our code line by line. The first line, Pragma Solidity 0.8.0, specifies the version of Solidity compiler to be used. It ensures compatibility with the syntax and features of Solidity version 0.8.0 and above. The next line declares a new contract named Message Contract. Contracts in a Solidity are similar to classes in other programming language. The next line declares a state variable named message of type string. The public keyword means that Solidity will automatically generate a getter function for this variable. The next line declares a public function named setMessage that takes a single argument message of type string memory. The memory keyword specifies the data location for the string. The next line inside the setMessage function, the line sets the value of the message state variable to the value of underscore message argument. And the next line closes the setMessage function. Now, next line declares a public view function named getMessage that returns a string memory. The view keyword indicates that the function does not modify the state of the contract. Return message inside the get message, this line returns the current value of message state variable. The next line closes the get message function and the next line closes the message contract. To compile and deploy the smart contract, follow these steps. Initialize a new Truffle project with Truffle init. The Truffle init command creates a new Truffle project with a standard directory structure. Create the smart contract file in the contacts directory. Write the deployment script in the migrations directory. Deployment scripts are placed in the migration directory and help Truffle manage the deployment of smart contracts. Start the Ganesh AI local blockchain instance by running Ganesh CLI. Compile the contract using Truffle compile and deploy it to the local blockchain with Truffle migrate network deployment. Now here is the example of deployment script. We'll see it line by line. Const message contract equal to artifacts.require message contract. This line imports the compiled contract artifact named message contract. The artifact.require method loads the contract's JSON representation generated by the compiler. Module.exports equals to function deployer. The line defines a function that takes a deployer object as an argument. The deployer is used to deploy contracts to the blockchain. Deployer.deploy message contract. This line instructs the deployer to deploy the message contract to blockchain, and the next line closes the module export function. Next, we'll develop the frontend using HTML, CSS, and JavaScript. The frontend will include input fields for the message and buttons to set and get the message. This is like creating the user interface where user can interact with the backend logic. HTML is used to structure the content of web pages, CSS is used to style the HTML elements, and JavaScript is a programming language that allows us to add interactivity and dynamic behavior to our web pages. I hope you are familiar with all these three languages. So here is our HTML front-end code. I'll explain this code to you line by line. The first line declares the document type and version of HTML being used. The second line opens the HTML document. The third line opens the head section which contains meta information about the document. The fourth line sets the title of the web page which appears in the browser tab. The fifth line closes the head section. The next line opens the body section which contains the content of the web page. The next line displays a heading with the text simple DApp. The next line creates an input field with an ID of message input and placeholder text enter a message. The next line creates a button that calls the set message function when clicked. The next line creates a button that calls the get message function when clicked. The next line creates a paragraph element with an ID of message display which will be used to display the message. The next line includes the web3.js library from a CDN. The next line includes the JavaScript app.js which contains the logic for interacting with the smart contract. The next line closes the body of the body, and the next line closes the HTML. To connect the frontend to the smart contract, we'll use web3.js. This involves setting up a web3 interacting with the smart contract and updating the UI based on user interactions. Now, now I'll explain this code to you line by line. The first line creates a new instance of Web3 and connects it to a local Ganesh blockchain running on port 8545. The next line defines the ABI application binary interface of smart contract, which is a JSON array that describes the contract's methods and events. Replace ABI array with the actual ABI of your contract. The next line sets the address of the deployed smart contract. Replace this contract address with the actual address of your contract. And the next line creates a new contract instance with the ABI and address of message contract. Now we make two functions for set message and get message. Here the first line declares an asynchronous function named set message that will be called when the set message button is clicked. The next line retrieves the list of account from local blockchain, and the next line get the value of message input field. The next line calls the set message method of the smart contract and sends a transaction from the first account, and the next line closes the set message function. The next line declares a asynchronous function named getMessage that will be called when the getMessage button is called. The next line calls the getMessage method of smart contract and retrieves the message. Next line sets the inner text of message display paragraph to retrieve messages, and the next line closes the getMessage function. Now we can interact with the DApp through the front end by setting and getting messages. This is like using the controls of a machine to perform action and see the results. Testing the DApp involves verifying that messages can be set and retrieved and that the UI updates accordingly. First, open the frontend in the web browser, then enter a message and click Set Message. Finally, click Get Message to retrieve and display the message. For deploying to the testnet, obtain a testnet ether. Obtain testnet ether from a faucet to fund the deployment of smart contract to the testnet. Then config truffle by updating the truffle config.js file with the necessary settings. I'll show you the JS code on the next slide. And then finally deploy the contract using the truffle command truffle migrate network Robston. This is the JS code we will be using. Here, basically, it includes HD wallet provider, which setups the provider for Robston using HD wallet provider. Don't forget to replace your Infura ID with your actual project ID and your MetaMask mnemonic with your actual MetaMask mnemonic. And the other things are pretty obvious, like skip dry run will skip the dry run, time blockout will add the time, and this is the GS code we will be using. In conclusion, we have covered the entire process of building a simple DApp, from setting up the development environment and writing the smart contract to developing the front end and deploying the DApp. I hope this tutorial has provided you with solid foundation for creating your own DApp. Remember to continue learning and experimenting with more advanced features and functionalities. At the end, here is a quiz for you. Please make sure to make the project on your own to have a better grip on the project. Thank you.